Okay, so exercise 6.3 goes on a little bit, so we're split up into two parts. So let's have a look at the first part, and the first thing we're going to do is find the total resultant forces in the x and the y direction. Sum up the forces in the x. I'll put a note that it's a resultant force, and I will use the cosine to sort out the angles, whether they should be positive, negative, and just dump them into my function. So I'm going to have 20 times cos 30 plus 15 times cos 125. Okay, so I'm just going to dump those numbers straight into my calculator and find the result. So we've got 20 times cos 30 plus 15 times cos 125. Right, so that is a working calculation, so we're going to do that to 5 significant figures. So 8.7169. Now let's sum the forces in the y direction. So we're going to sum up the forces. They're going to be the y direction, and so remember that they are going to be a resultant. So all we need to do is look at this thing above and replace the coses with sines. 20 sine 30 plus 15 sine 125. Right, so let's dump that into my calculator. So we've got 20 times sine 30 plus 15 times sine 125. Okay, so that equals 22.56 fig 287. Right, so notice that the original form was a force times a direction, a force plus a direction. So we want to give a force and a direction as a final answer. First thing, we could write this out, the equilibrium force in terms of Cartesian, but it's not really what we're looking for. So we could call this force and call it an equilibrium. I suppose I would. Yes, it's equilibrium, EQ maybe, EQR or something like that. So so the x in the x component, if we're going to do Cartesian vectors, so 8.7169i, and the other one obviously equilibrium, so it's negative of that result, so minus that result, and then minus 22.287j, and these are all going to be newtons. So draw yourself a little diagram and say, where am I roughly pointing? Well, we're going in the negative x direction, negative y direction, so we're down here. So the angle we're looking for is going to be this angle here. So when I put this into my calculator and I do it at an arctan, I actually expect to get this angle here appearing. So I'm going to have to convert this angle to give me this result here. But before I'm going to find the angle itself, I'll find the magnitude. So the magnitude of the equilibrium or the resultant are both going to be the same. When I do magnitudes, I am just going to ignore whether there's a plus or minus sign there, because when I square a minus, I should expect a positive, and when I square a positive, I expect a positive, so I just ignore it. So 8.7169 square it plus 22.287 square it, and then do a square root. So we put that into our calculator. So we're going to have 8.7169 square it, okay, where can we see it? You can see it here, plus 22.287, let's square it, so that's all combined. Let's do to the square root of my answer, So that's the number. So we've got 23.931. So it kind of makes sense. We expect it to be a bit bigger than the 22, but not dramatically. Okay, so that's the force. Now for the angle. So what we're going to do for the angle, as I said, we're going to do theta equals arctan, or if you prefer tan inverse function. The opposite is the value on the j side, so that's j. So that's going to be the 22. So notice I'm dividing the minus divided by minus. So I will put that in, but obviously I know a minus divided by minus gives me positive. Minus 22.287. So I'm not cheating, there's nothing magical going on here. Minus 8.7169. So let's find that angle, or at least the angle the calculator thinks the result is. So inverse tan, we're going to do minus 22.287 divided by minus 8.7169. Okay, so that gives me a angle of 6, 8, 5 sig figs, we haven't finished, 639 degrees. Right, as I said, that's going to be that angle there, but we want this negative angle there going from the horizontal. So the actual result, therefore, is going to be, so that's my theta 1 result, actual result is going to be 68.639, take away 180 degrees, and I can't fit it in there, so can I state what that answer is? So we got that, take away 180 degrees, and that is minus 111. Well, that's good enough for a final answer. So 3 sig fig 111. Okay.